what topic should we focus on today? Is it going to be A, general chemistry, B, organic chemistry, C, physics, or D, calculus? Jackson is locked in. Amara, welcome in. We got our first problem up on today. A CO2 plus H2 gas reacts to form, okay, CO gas plus H2O. And our task for today, for our very first practice problem, is all we have to do is write the equilibrium constant. Today we're going to start off by talking about equilibrium. If this is a good topic, let me know. You can always talk about equilibrium. So the way I have to do this is notice that everything is in terms of gas, right? So we're going to write the Kp expression, the Keq rather, is going to be basically what? Products divided by reactants. What's Keq? If you're taking general chemistry, this is going to be for general chemistry or AB chemistry. So it's going to be products divided by reactants. Audio is super quiet on YouTube. Music is too loud. Dang. Good to know, good to know. Okay, so maybe we'll configure this. Hold on a second. In the meantime, let's go ahead and see what is this. There we go. I'm gonna cut that. What about that now? Thanks for that. So I want to see, and let's go ahead and calculate this Keq, guys. We're gonna say that this is the products over reactants. This is the partial pressure of CO. Okay, the partial pressure of CO. Okay, and then we're not going to include the partial pressure of water. Why? Because it's a liquid. It is not a gas. It's not going to have partial pressure included. Then we're going to divide that by the partial pressure of CO2 times the partial pressure of H2. And we're pretty much done. So once again, this is our very first problem. This is simply just the K equilibrium constant. This is going to be how you write the equilibrium expression. So this is going to be our very first problem for today. And we're going to do another example so that you know how to write equilibrium expressions here. Suppose I give you this formula here. SnO2 solid plus 2CO gas is in equilibrium to form SN solid. Thank you, Jackson. Jose, welcome in. K, Edward, welcome in. Plus 2 CO2. Good question. Which way did it shift? That's a really great question. We don't have any information for this particular example, but that's exactly what's the purpose of this chapter. This is the chapter on equilibrium in AP chemistry and general chemistry. At the moment, we do not know which way did it shift because we don't have any of those values yet. Okay, all we want to do is get used to writing the equilibrium constant. Once you get used to writing the equilibrium constant, it's all going to make sense. So I'm going to write this as Keq. So what is it for this time, chat? What is the Keq for this expression here? It's going to be PCO2. Do we include solid? Question for y'all. Do we include solid or do we neglect solid? Do we include or do we neglect solid in this case? Shamu, welcome in. Guys and gals, anyone that's just joining in, we are doing some practice problems today. Make sure you vote on which topic you want to see. General chemistry, organic chemistry, mathematics, or physics. Let's see how many votes we have so far. It's been about 5 minutes. Okay, so this Keq, guys, we got no votes. Guys, make sure you tap on the top left-hand side of your screen if you're on live on TikTok. Okay, so I'm going to neglect any solid terms. I'm only going to focus on the gaseous quantities. So I'm going to focus on PCO2. And this time I do have a coefficient, which is the number 2. So I'm going to put PCO2 and square that term. Why? Because that is going to be our coefficient. Squared is our 2. Thank you, Jackson. First one into the vote. Guys, if you want to vote, tap the top left-hand side of your screen and select a course. Jackson is the first one to vote. Autumn, welcome in. Christian, welcome in. Leela, Bali, and Diana, welcome into the chat, my friends. How's everyone doing? And then now on the bottom, we have to similarly do our partial pressure. We're going to neglect SnO2 and SN solid. Why? Because they are solid. We do not include solids in the equilibrium expression. There we go. We got another vote. Christian just voted for organic chemistry. All right, and this is going to be PCO squared as well. And we're pretty much done here. Let me just highlight this one as well. And guys, anyone that is new, just joining into the chat, welcome in. I am Dr. Drew. I go live every single week to answer your STEM questions. So let me know if there's any questions about this particular problem. And guys, we're going to do one more equilibrium before I do another quick check in on the chat. You're free to ask me any questions you might have about STEM, whether it's Gen Chem, organic chemistry, mathematics, or physics. It's basically on a first come, first serve basis. Let me know what's everyone taking this semester. I know it's just the start of the school year, but you know, it's always good to have a good head start, right? So what's everyone taking this semester? Are you taking math classes? Are you taking bio classes? Hey, Mathematic Fanatic. Shouts out the Mathematic Fanatic. He has a really sick channel, guys. Really appreciate that comment. This is AP Chem, also general chemistry. So this is going to be seen. This particular example is equilibrium. We're going to see this in general chemistry and AP Chem. Cynthia, welcome in. Acids and bases. All right. So this is going to be pretty much related to acids and bases. Christian, you're going to be the very first request for today. So let's go over acids and bases right after this very next example. Kevin says only organic chemistry. A and P, med term. What's A and P? Okay, guys, so how do we write the equilibrium expression for this particular equation here? So notice that we have KEQ equals SN2 plus H2 gas, right? So how do we go ahead and set this expression, chat? Oh, anatomy and physiology, got you. So remember, we're always going to ignore anything that is solid, so we're not going to include SN. It's always going to be products over reactants, okay, chat? So products over reactants. So what do we have for products? This is going to be our concentration of SN2+. That's the product. And what else do we have? The partial pressure of H2. Good job, Christian. And kinetics. Samrit, got you. Okay, guys, so here's what we're going to do. We're getting our first request for today. I'm going to finish up this last example, and then we're going to jump into acids and bases, followed by kinetics. And guys, if you have any questions, feel free to drop them down below. It's going to be a first come, first serve basis. The last thing we have, remember, always ignore solid. We do not include solid. And then it's going to be H plus here on the bottom, H plus quantity squared. Okay, so this is how we write the equilibrium expression for this particular example. There we go. Okay. No solids. Very good, Christian. So, guys, I know that the AP test is coming up in May. So, you're in AP chemistry or college chemistry, I'm going to do lots of practice problems here on my channel to make sure that everyone's prepared. Okay? All right. So, Christian asked about acids and bases. So, I'm going to go ahead and give you guys an overview about acids and bases. And anyone that is taking organic chemistry, this is going to be a review for you. But make sure that you vote up on the chat. On the top left hand side of your screen, we have the poll active. 30 minutes left on the clock. What topic should we focus on today? So is it going to be A, general chemistry, B, organic chemistry, C, physics, or D, calculus? And so to vote, all you have to do is tap that button on the top left hand side of your screen. So for example, one vote for Gen Chem, one vote for OChem. All right, guys. So what is a good definition for acids and bases? How do we conceptualize? There we go. We got one more vote for C. C is going to be physics. We can definitely do physics, guys. It's an even tie right now. Okay, so what is a good definition for acids and bases? So who can tell me a good definition for acids and bases? Remember, acids, let's talk about strong acids for now. So let's talk about strong acids versus strong bases, and then we'll talk about weak acids versus weak bases. So who can tell me a good definition for a strong acid? I do have this topic already up on my channel, so just swipe right to my profile if you want to review acids and bases. So strong acid is going to be something of the form of HA. Very good. Acids are proton donors, and bases are proton acceptors. Very good. That's the Bronsted-Lowry definition. So acids are going to be proton donors, and they're going to fully deprotonate. They're going to fully dissociate. Okay? And so that means we're not going to have equilibrium, right? Sometimes people get confused. How do you know if it's a strong acid or a weak acid? Well, if it's a strong acid, it's going to fully deprotonate. So what do I mean by deprotonate? H is the proton, right? HA is the acid and H is the proton. So that's going to be represented by H plus and then A minus. So chat, what is H plus? What's the difference between H plus and A minus? So H plus is what? What's the name of H plus? And then what is A minus? So if you see HA, I want you to realize that's going to be the acid. In this case, it's a strong acid. H plus is the proton. And then A minus is the conjugate base. Okay? Guys and gals, do me a big favor and drop a thumbs up if this is making sense so far. So if this is making sense and you're following along, go ahead and do me a favor and drop a thumbs up emoji down in the chat to make sure that this is making sense here. And if you're a little bit confused, drop a crying emoji. Concentration of H plus ions in solution. In neutral water, all are H2O molecules. All in that form do they split apart, like A equals OH. Samrit says thumbs up. Thank you, Samrit. Okay, so in neutral water, are all the H2O molecules all in that form, or do they split apart? I'm not quite sure I understand your question, math fans. So in neutral water, let's go ahead and just conceptualize neutral water. Oh, yes, very good question. Now I understand your question. So neutral water is going to react with itself. This is a very good question, guys and gals. So H2O is going to react with itself to generate hydronium, which is going to be H3O plus and OH minus. So on the left-hand side, we have H2O as water. So let's label the left-hand side as water. And the right-hand side is going to be H3O plus and hydroxide, OH minus. That's because water is amphiprotic. This is really important, chat. If you're taking AP Chem or Gen Chem, it's really important to know if something is amphiprotic. So amphiprotic means that it's going to function as both an acid and a base, because we're going to generate H3O plus hydronium. Hydronium is going to generate H plus ions, and hydroxide is going to generate OH minus ions. And so the question is, how do we know essentially, the question is, do they all form or do they split apart? And that's going to depend on the pH of the solution. So there's a formula for pH given by the following. pH is equal to the negative log of the concentration of H plus ions. Okay, so this formula is going to be one of the most important formulas. That's going to tell us the acidity. Let's write this down. pH tells us the acidity in solution. Okay, so let's do a simple example where we have the solution of HCl concentration. So HCl is going to be approximately, let's say that's 1 molar. Let's say something crazier. Let's say that's going to be 0.32 molar. So the concentration of HCl acid is 0.32. Okay? Does a single H2O ever split into H plus and OH minus? Technically, no. It's never going to really split, but it can't. Well, that's the thing. It's like a nuance. Let's just say yes. Let's just say yes. But it's a nuance in Gen Chem. That's the difference between Gen Chem and physics. Gen Chem is just a theory, and physics is more of like empirical. So you're never going to see this happen in real life, but technically this is the general formula, okay, for H2O. Great question. So if I have 0.32 molar of HCl, how do I calculate the pH of this solution? Well, I'm going to effectively apply the formula. pH is equal to the negative log of the concentration of 0.32. Okay, and this is log base 10, by the way. So I'm going to go ahead and just compute this on a scientific calculator by taking that value. And that's going to be negative log base 10. Negative log base 10. Okay, of 0.32. Okay, so the pH is extremely high. We got 0.49. Extremely low, rather, 0.49. And so that's extremely low. Anything that is low pH is going to be what? Strong acid or strong base? Loud out calculator. Oops, sorry, let me bring this down. Is something that is a low pH, does that mean that it's highly acidic or highly alkaline? Let me know, chat. Is something that is a low pH, is that highly acidic or highly alkaline? Very good. So anything that has a low pH is going to be highly acidic. So make sure you understand how to use the formula for pH. It's going to be negative log of the concentration of H plus. Now, I remember that there's one question on the AP exam, and you do need to know the formula for dilutions. Chat, have you guys gone over dilutions in AP Chem and general chemistry? The formula for dilution is given as the following. It's basically C1V1 equals C2V2. And so that's going to be telling us that we have effectively two solutions. Okay, this one's going to be C1V1. And so the molar concentrations can be different here, but they're going to have the same value of moles. Okay. Is there a significance to 0 pH, or can it go lower? Yes, it can actually go lower to negative, but at that point it's non-significant, meaning it's just highly extremely acidic. There's no physical meaning. There's no intuitive way to understand anything below 1 is just highly acidic. However, we can intuit the the pH of really, really acidic solutions based on their pKa value, which we'll talk about shortly. pKa value tells you how acidic an acid is. Yeah, Jackson says superacids, or they're just commonly referred to as strong acids. Okay, and oh, actually, you're talking about fluoroantimonic acid. Interesting. I'm not 100% sure about that particular acid. Okay, so in this example, we're gonna just talk about dilutions, which is super common, and you can fall into some traps. So let's suppose that I give you the concentration of this solution here is, let's say that the concentration of this solution is, as a matter of fact, I don't even give you the concentration. I'm gonna give you the pH. I'm gonna give this as pH 3, and then I'm going to give you this as pH 7. This is neutral. Okay, so this one is going to be acidic, and then this one here is going to be neutral. Okay, and so our task, let's suppose that the volume of this solution is approximately 10 liters. Okay, and so our task is to solve for V1 such that we can neutralize the solution to become acidic. Okay, so this is a very common question that you can expect to see on AP Chemistry, practice, and Gen Chem in college chem. All right, guys, let's take a look at the poll. How are we doing? It's already been 20 minutes. And let's see what we have so far. We got general chemistry, organic chemistry, math, and physics. And most of the votes today are, in fact, for general chemistry. So I'm going to keep it going. But once again, make sure to keep voting by tapping that button on the top left-hand side. All right, so hopefully I designed this problem carefully enough. So what I'm going to do is I'm going to apply the formula C1 V1 equals C2 V2. And I'm going to start to plug in some of these values. But the problem is I don't know what my concentration is. So I need to use my other formula for pH, which is negative log of the concentration of H+. So this is where you have to recall your mathematics, your algebra. So how do I use algebra to solve for the concentration of H+? Remember, C stands for concentration. So I need to use algebra here. Namely, I need to do what mathematical operation to solve for H+ here? If this is a variable here and this is negative log of H+, what do I got to do to solve for H+? I'm basically going to do 10 to the power of both sides. Very good. Caffeine. Good job, caffeine. Caffeine got it. So caffeine said take 10 to the power of both sides. So that way I can cancel out that log. And therefore, I'm going to say that a new formula effectively is H plus concentration equals 10 to the minus pH. All right. So now I have 10 to the minus pH, and now I can start to plug these values in. So I have 10 to the minus 3 times V1 equals 10 to the minus 7, because that's pH 7, times the concentration, times V2, which was 10 liters. Okay? So I'm going to divide both sides by 10 to the minus 3. And effectively, let's see what we get here. We see that V1 is effectively 10 to the minus 7 divided by 10 to the minus 3. Now at this point, yes, you can use your calculators because you will be allowed to use calculators on exams usually, right? But let's just do a little bit of math. Let's see if we can do this. Okay, so V1 is going to be extremely large now. So that's going to be 10 to the minus 7. And recall your order of operations, chat, is going to be a negative 3 times 10. So V1 got to be a 10 to the minus 7 plus 3 times another 10, which is going to be a 10 to the minus 4 times a 10 to the 1, which is going to be a 10 to the minus 3 liters, which equates to 1 milliliter. Okay, so our final answer was 1 milliliter. Let me zoom out so everyone can see that. Meaning, what does that mean? That means if we have a solution of acid that we want to neutralize, okay, and a neutral pH is approximately 7, and we want approximately 10 liters of that, and our acidic solution is pH 3, how much volume of that do we need? That's going to be 1 ml. School feels real optional right now. It does, doesn't it? So we're going to need 1 milliliter, 1 ml of the acidic solution to neutralize into a 10 liter solution. That's going to give you some idea about some instance of concentration. Is the 0 and 7 of pH more like the 0 and 100 of Celsius or the 0 of Kelvin? Okay, so we're talking about the pH scale versus the temperature scale. So let's talk about that real quick because those are similar ideas but different units. The pH scale runs from about approximately 1 or even less to 7 up to 14. So anything between 1 and 7 is what? Anything between 1 and 7 is what? Is that acidic or basic? Versus temperature is going to be a little bit different. So anything between 1 and 7 is going to be acidic, right over here, right? Anything between 1 and 7 is going to be acidic. And everything between 7 and 14 is going to be basic or alkaline. I'm going to call this basic, okay? And so that scale is pretty much arbitrary. There's no way to know what that would be. And then the question is, what about Kelvin? Okay, so we also have 0 to 100 degrees Celsius. And this is going to be in Celsius versus Kelvin. So Kelvin is absolute. So Kelvin doesn't really have an upper limit. It's just going to be 0 Kelvin. And then this is going to go up to infinity. So it's kind of hard to answer your question because we're comparing apples to oranges. So there are 3 different scales. This one is for pH, which measures acidity. Okay, compared to temperature, which measures, well, temperature, that measures motion. Okay. Michael, can you explain what that 1 ml represents again? Got you. Of course. Ooh, BS in chemistry. Good job, Caffeine. Good to have you. So what we did, our calculation here in this example was a dilution calculation here. And our final answer was 1 ml. So what was 1 ml? What was 1 milliliter? So the question was, suppose we have an acidic solution and a neutral solution. And in our neutral solution, we have a pH 7 because pH 7 is neutral. And our volume for the neutral solution is 10 liters. And our pH for the acidic solution is 3. So what volume do we need to dilute? Dilute means you're adding water, okay? Dilute means you're adding water. So what volume of the acidic solution do we need? And we only need a little bit. We only need 1 milliliter of that solution here, according to our calculations. So 1 milliliter was all we needed to neutralize to create a 10-liter solution of, neutral. Okay? So guys, hopefully that's making sense here. And guys, that's going to be our first topic for today. Let me just go ahead and check the chat and let's see how we're doing with the poll. The first thing we did was equilibrium and then acids and bases. And guys and gals, anyone that's new here, I'm Dr. Drew. I go live every single week to answer your STEM questions. If you want, you can ask a question down in the chat below. Next one was kinetics. So guys, if you think kinetics is a good topic to go over, go ahead and drop a thumbs up emoji if you want to see kinetics. We got 3 votes for Gen Chem and 2 for organic chemistry. If you want me to switch to another topic, make sure you vote in the poll. We got only 12 minutes on the clock today. So you will take 1 milliliter of acid and dilute it with 9 milliliters of H2O to get the neutral solution. That's exactly correct. Except the only thing is that this is in liters. Okay, so I will take 1 milliliter of the acidic solution and take 9.99, I believe. Let's go ahead and do a follow-up calculation. Let's do a follow-up calculation. So I'm just going to call that FC for follow-up calculation. Okay, and so the calculation is if we take 1 ml of acidic solution, pH 3, well, how much water do we need to do 10 liters? So that's just going to be 10 liters minus 1 ml. But 1 ml is 1,000, so I'm going to do 10 minus 1 divided by 1,000. And that's going to be liters. So that's going to be 10 minus 1 over 1,000, which is 9.999, I believe. So 9 milliliters of water plus 1 milliliter of acid. Okay, so I kind of just made up that problem up in my head. Okay, great question. So how should you be studying for physics? For physics, I recommend doing none other than understanding what equations you're looking at. Okay, for instance, kinematics, energy, work, motion, centripetal force, whatever topic you're looking at, understand the equations, number 1. Number 2, learn the application of that equation. What do I mean by application? I mean by doing the practice problems, answering as many problems as you can. Where does the equation come from? Number 1, and number 2, more importantly, application. That means answering the problems. Okay? Yeah, 999 milliliters. This should be a 9.999. Yeah. So yeah, guys, let me know if this is helpful so far. If you guys want, we can switch to different topic here. I think the next one here I will go ahead and do. It can be Gen Chem or it can even be organic chemistry here. So I'm going to go ahead and start to draw some new examples, some new topics. What if we do this next example here? So I'm going to go ahead and do this exercise here. Back to equilibrium. So anyone that is taking AP Chem or General Chemistry 2, you are going to see this expected. You are going to be expected to know this topic here. So this is a very common example known as the Haber-Bosch process. It's going to look something like this. Okay, and so our first equilibrium expression is going to be N2 gas plus 3H2 gas is in equilibrium to form 2NH3 gas. Okay, now I'm going to give you some data in this case, chat. I'm going to give you some data, and we're going to calculate a different quantity here this time. We're going to calculate the KEQ. Okay, so the equilibrium mixture of gases was analyzed and found to contain these concentrations here. So we're going to say that the partial pressure of each species was given as follows. And this is going to be in ATM. Okay, and let's suppose I give this to you in ATM, and that's going to be 7.38. Okay, H2 gas is going to be 2.46 ATM, and then we're going to have 0.166. 0.166. So what we got to do, guys, is we're going to basically write the K equilibrium expression, KEQ. All right, so KEQ is going to be products over reactants always, okay? So what is KEQ? It's products over reactants. So what's our product here? It's going to be the P sub NH3. That's the partial pressure of NH3 quantity squared divided by the partial pressure of N2 gas times, well, what do we have as the reactant? That's going to be the partial pressure of H2 to the third power. But guess what? We already have 3 of these quantities. We already have the partial pressure of NH3. We're going to square that. And then we're also going to divide by the partial pressure of N2 and H2 gas. Okay, so that's going to be our first value. What is that, chat? That's going to be 0.166 squared divided by 7.38. Oh, hold on a sec. I got these numbers mixed up. This one for N2 gas is 2.46. Okay, so that's going to be divided by 2.46 times 7.38 to the third power. All right, and if you plug that into expression, you're going to get KEQ equals 2.79 times 10 to the minus 5. Okay, so that's going to be our next example here. All right, so let me know if there's any questions about that. Otherwise, we're going to continue forward. And so let's suppose I give you another example. We're going to talk about ice tables next. We're going to talk about ice tables, also known as rice tables. Okay, so here's how to write an ice table. So to write an ice table, we're going to basically say that NH3 aqueous plus H2O liquid is going to give us NH4 plus aqueous plus OH minus. So in our ice table, we're going to basically have this expression and then do the initial. We're basically going to say this is going to be the initial, change, and then equilibrium. So that's what I mean by ice table. Ice stands for initial, change, equilibrium. All right. So initial, change, equilibrium basically going to be given. Okay. So let's suppose that initially I give you 0.0124 molar ammonia, NH3. And so initially we're not going to really have anything for water. That's going to be our solvent. That's not going to change. Jaden, thank you for the follow. P2, thank you for the follow. Welcome in. Asan, welcome in. And then for ammonium, we're going to say that's 0 initially, okay, as well as hydroxide. But over time, through equilibrium process, they're going to shift to the right. I miss doing these. Going to have to retake my Gen Chem courses in the future. Oh, really? Do you have to retake Chem? Interesting. Yeah, these are pretty fun. So what I'm going to do now is I'm going to do an ice table. So I'm going to say, I don't know what this is going to be. So I'm going to say this is going to be an X. Okay? I'm going to say this is going to be an X. And I think in this case, they gave it to us. They said that OH minus was given as 4.64 times 10 to the minus 4 molar. Okay? So if something is decreasing, we're going to represent that by a minus X. I'm going to put that in red. And then if it's increasing on the product side, I'm going to represent that with the positive X in blue. Okay? So in total, I'm going to say this is 0.0124 minus X and then a plus X. Now, what's interesting is that they already gave us x here. So they said that x is basically 4.64 times 10 to the minus 4. So that was already known. So I'm going to box that. I'm going to say that x equals 4.64 times 10 to the minus 4. And that's effectively our first solution because that's going to be the concentration of NH4 plus is that same value. And then all I have to do is take 0.0124 minus 4.64 times 10 to the minus 4. And that's going to give us approximately 0.0194 molar. All right. So now we effectively know everything in equilibrium. So all we have to do is write the equilibrium expression. And so what's the equilibrium expression? Remember, it's KEQ equals products over reactants. So the products are going to be effectively a 4.64 times 10 to the minus 4 molar. But we're going to have to square that. Why do we square that? Because we have an NH4 plus, which is an X, and then an OH minus, which is also that same value, which we already solved for X. Then we're going to divide. Then we're going to divide by that term 0.0124 minus x, which we already said was 0.01194. Okay? And if we plug those values into a calculator, we're going to arrive at 1.8 times 10 to the minus 5. And that's going to be our final answer for a KEQ. Great. All right, guys and gals, we're going to do a quick check-in. Guys, we have 1 minute left on the poll. We only got a few votes today. I'm assuming that people are still not back in school, so it feels a little bit quiet today, but that's perfectly fine. We have 1 minute left on the poll, and the question of today was, what topic should we focus on? We got 3 votes for Gen Chem, 2 for Organic Chem, 1 for Physics, and 1 for Calculus. And guys, it's not too late to vote and invite your friends into the chat to see if you have any questions you might have. So our first few topics today for general chemistry, we went over equilibrium as well as acids and bases. And this topic is extremely fundamental, super important for AP Chem and General Chem. All right, awesome, guys. We got just another vote come in for Gen Chem. So Gen Chem cooked today. Awesome. 3D11H, thanks for your vote. That's right, guys. This is basically what you're going to see in Gen Chem 2, Florida kid. This is Gen Chem 2, or AP Chem. And the first thing you're going to learn about is ICE tables, also known as rice tables. And guys and gals, let me know what's the next topic. Should we continue to do more examples? How about an overview of what to expect for Gen Chem? Or the AP Chem exam. So once again, for ICE tables, this is the very first thing you can expect to see. For rice tables, we're going to have equilibrium. So what does equilibrium mean again? It basically means that we're going to have a forward reaction and a reverse reaction. Remember in Gen Chem 1, or in the first half of chemistry, you have only a forward reaction. Well, now you're going to have a forward reaction and a reverse reaction. I'm so glad I'm done with chemistry. It gave me my first panic attack. Oh no, I'm sorry. AV, I'm sorry that happened. So equilibrium is we're going to have both a forward reaction and a backwards reaction. And as we saw, we had that forward reaction generating our products, and then a reverse reaction reverting to form the reactants. Period. Thank you for the follow. Saeed, math teacher, Aya, welcome in. And so in this particular example, they gave us the hydroxide ion concentration. What was that again? Remember, they said that was 4.64 times 10 to the minus 4. Thank you for the bunch of new follows. I'm sorry if I missed you. Ryan, just got a bunch of new follows right there. I'm sorry if I missed your name, but appreciate the support. And guys, so we said that 4.64 times 10 to the minus 4, that was the hydroxide ion concentration, right? So we also note that's not only the hydroxide ion concentration, that's also going to be the ammonium ion concentration. So next, I want you to realize that this is also acids and bases, okay? So in acids and bases, let's do an example in which case we can see the change in concentration and write an ICE table for that. So this is what you're going to expect to see this semester, guys. Is anyone taking General Chemistry 2 this semester? Let me know. Who's taking Gen Chem 2 this semester, guys? Or who's taking biology? So I'm going to pull up another example here. Just bear with me one sec as I pull this up. Okay, Florida Kid says me. 3D1 says me. Okay. So how do you guys feel about Gen Chem 2? Are you feeling excited or a little bit nervous? Here's what you're going to expect here. Okay? So it's all about equilibrium. And remember, equilibrium basically means that basically means you're going to have a forward reaction between reactants and a reverse reaction for the products. Okay, this is going to be the very first thing. User says a little bit nervous. That's fine. Andy says I passed Gen Chem 1, but can we go over oxidation rules? All right. Excellent. Let's go over redox. You're going to see that again in Gen Chem 2, guys. If you went over redox, oxidation, reduction in Gen Chem 1, you're going to see that again in Gen Chem 2. So let's go over redox. Okay. So what is redox? What does redox stand for? Did you guys go over that topic already, or is this something brand new to you? So redox is going to stand for oxidation plus reduction, right? Oxidation plus reduction. So does anyone know what is the definition of oxidation? And what is the definition of reduction? Okay, so I'm going to give you an example. Let's suppose that we have this. Let's suppose that we have this equation right over here. We're going to have Zn solid. So something that is oxidized, what does that mean? What does that word sound like? Oxidized? Doesn't that sound kind of like oxygen? So that's going to be Zn2 plus in the product, aqueous plus H2 gas. All right, so what you do have to memorize, chat, is the oxidation states. Okay? Exactly, Florida Kid says gain electrons. So oxidation is going to be something that is going to be losing electrons. It's the process of losing electrons. And reduction is gaining electrons. Reduction is gaining electrons. And there's two acronyms to memorize this. The one that I did was oil rig. Okay, oil rig for oxidation is lose and reduction is gain. And another one that people do that's perfectly fine is it's Leo goes grr. Leo goes grr. So that's how you memorize Leo grr is oxidation versus reduction. Oil rig. Very good. All right, so in this case, we have Zn solid and 2H plus. So I know this may be a challenging topic, but we're going to break it down together. So Zn solid, anything that is solid is always going to be plus 0. So we're going to take a different color pen. I'm going to just use blue. And anything that is solid is 0. So I'm going to put plus 0. And I'm just going to put a little note down here for people to understand that solid equals plus 0. We're just going to just box that. All right, beautiful. And then anything that is on the left-hand side of the column, in this case, hydrogen is plus 1. So chat, I just encourage you to memorize that. So memorize anything that is on the left-hand side. Lobos, thank you for the follow. Love, care, respect, welcome in. And, well, 2 plus is already given, so we don't really need to do anything here. So I'm just going to put that up on top here. And anything that is diatomic is also 0. Anything that is diatomic is also plus 0. So I'm going to put this as plus 0 on the right-hand side here as well. Brilliant. Music is too loud? Yeah, I got you. Hold on a sec. Let me lower down the music. And guys, in a moment, we're going to go ahead and see. We're going to go ahead and see. Hold on, guys. Let me lower the music. Sometimes people like the music. Sometimes it's too distracting. Sometimes people like the music because it helps their focus. Sometimes people think it's too distracting. Okay, how's this for the music? Is this There we go. Is that better? All right. So we have this reaction here is Zn solid. And by the way, guys, anyone that is new here, my name is Dr. Drew. I go over STEM questions every single week. Today we're going over general chemistry. All right, and then we have Zn solid and 2H plus. So if you have any questions, drop them down below. So which one of these is getting oxidized? Which one of these is getting reduced? Linklet, thank you for the follow. Which one of these is getting oxidized? Which one of these is getting reduced? Thoughts on linear algebra? Super important for computer science and any STEM majors. So I love that subject. I would just suggest, as I always say, for all this math classes, doing a ton of practice problems, understanding the theory, understanding vector theorems, and vector transformations. All right, guys. So as we can see, Zn solid is +0 currently here, and then it's going to +2. So if it's going from +0 to +2, is it gaining electrons or is it losing electrons? Is it gaining electrons or is it losing electrons? Similarly, from +1 to +0, is this gaining electrons or losing electrons? Very good. So +0 to +2, you're going to be losing electrons, right? +0 to +2, you're going to be losing electrons here because +0, let's look at one at a time. Zn was +0 and then it became Zn +2. So that means we're going to be losing 2 electrons. And we said that losing electrons was oxidation. Right? So let me know if you guys agree with that. Let me make sure if I'm not mistaken here, right? Okay, so the oxidation state of zinc changed from +0 to +2. So therefore, it's going to be losing electrons. Okay, so therefore, it's going to be losing electrons. Guys, if that makes sense, let me know. Let me just double check if I'm not mistaken here. Okay, so and then similarly, and then contrarily, hydrogen on the other hand went from +1, okay, to +0. So now is hydrogen losing or gaining? Let's do a quick poll, chat. Let's do a quick poll. Is hydrogen losing electrons or gaining electrons? We're going to do a quick poll. And guys, give me 1 sec to write this out. So is hydrogen, is it going to be losing electrons? And we're going to say happy face. Guys, let's do a quick poll so we can see how we're understanding this. Make sure we're on the same page here. Or gaining electrons. Guys, give me 1 sec as I pull up this poll. We're going to have 60 seconds on the clock. So you got about 10 more seconds to think about it as I pull up this poll. So is hydrogen, right over here in this particular example, is hydrogen losing electrons or gaining electrons? Okay, the poll is going to pop up on the top left-hand side of your screen. If you think that hydrogen is gaining electrons, you're going to vote for the happy face emoji. No, if you think that hydrogen is losing electrons, you're going to vote for the happy face emoji. If you think that hydrogen is gaining electrons, you're going to vote for the crying emoji. Okay, 60 seconds on the clock starting right about now. 60 seconds on the clock. So if you think that it's losing electrons, vote for happy face. If you think that's gaining electrons, vote for crying emoji. There we go. We got 1 vote, 2 votes for gaining electrons. All right, perfect. Perfect. We got 2 votes for gaining electrons. Who thinks it's losing electrons? So to vote, make sure you tap on the top left-hand side of your screen. There's a button there, and then you can select the appropriate emoji. There we go. We got 3 votes for gaining electrons. So if you said crying, why did you say gaining electrons? Layla, welcome in. Thank you for the follow. Appreciate you. Welcome in. Let's go. Welcome in. So 20 seconds left, guys. If you think it's gaining electrons or if you think it's losing electrons, let me know why. So notice that we have 2H plus here, right? So 2H plus, and then we go into +0. So +1 minus 1 equals 0. That's why we're gaining electrons. +1 minus 1 equals 0, right? So that means we are gaining electrons. Electrons have a minus charge. So if you said crying emoji, then good job, everyone that voted for crying emoji. You just cooked that up. We got 3 votes for crying emoji. So go ahead and drop a fire or thumbs up emoji because you guys just cooked that up. All right, guys, so that's basically the general overview for oxidation reduction. And once again, if you have any more questions, feel free to drop them down below. And guys, should we continue with this particular topic or move on to a different topic? What are the main things that you're going to see this semester? Are you guys taking general chemistry or physics or math this semester? Comment down below. So I'm going to go ahead and do another example here just to bring it home so that everyone understands. Because that's going to be one of the first things that you might see when you take this class here. So let's suppose that we have this compound, cadmium solid plus NiO2. This is going to be solid plus 2H2O liquid. So now we're going to have 3 reactants. All right, and this is going to be cadmium hydroxide solid plus NiOH2. Florida says Calc 2, Gen Chem 2, Physics, Cal based.